When we're factoring, no matter what we're factoring, what should we always try first?
GCF.
Greatest common factor, right? And that's in fact why we did it first, right? In our booklet, because we want to make sure that that's the first thing that we're looking for every time we do a problem, okay? Then we did difference in sum of squares, and we did difference in sum of cubes, right? How confident are you feeling with those?
Great.
Great. Great for a greatest common factor as well?
Yes, ma'am.
Okay. Then we did grouping. And you guys blossomed in factoring by grouping. You guys got that on lock, yes? Okay. Then yesterday we factored trinomials. You love this, right? You love it because we did the long way, right? Hey, let's talk through the long way real quick. We identified A, B, and C. We found A, C. So in this problem that was 6, right? And then we identified B. In this problem that was 5. And we said what two numbers have to multiply to be 6 and add to be 5? And we decided those two numbers was 2 and 3. So we took the middle term and just split it into the two parts you just told me. And then there's 4 terms, so we factored by grouping. Common term is x, what's left is x plus 2. Common term is 3, what's left is x plus 2. These two terms both have an x plus 2, and what's left is x plus 3. You remember that? How confident do you feel in that? Good. And then we realized that 2 and 3 were the original numbers we said that could be, and we realized that's what was in our factors at the end. And we know that when a is 1, we can do this shortcut, right? So what happens when a is not 1? We can't do the shortcut, but we can do this, right? So our notes for today, because we're on this page, right? Our notes for the day.
We're not pointing fingers, but
trinomials, a is not 1. It's going to be examples, except this. Like I've got 4 examples for you. 1, 2, 3, 4. But like I already showed you how to do it yesterday. So we'll go slow at the beginning, but I don't think we'll have to go too slow for too long. Does that make sense? Okay. So you ready to try one? Okay. So 2x squared plus 17x plus 21. So what do you think we need to do first?
AC.
AC. AC. So what, in this problem, what is AC?
42.
42. And in this problem, what is B? 17. So the factors of 42 would be 1 and 42, 2 and 21, 3 and 14. Oh, that one? I don't even need to write down the rest of the factors? I can if I want, right? Because the only one left is 6 and 7, right? Yeah. I'm sorry I didn't make it to where that one worked. Sorry. Okay. But no, I don't have to keep writing the factors, right? Do you have to write the factors like this?
No.
Well, why was I doing that? To help me find the 17, right? Okay. But I don't need to go any further because I know 3 and 4 will be the ones that work. So I need to rewrite my problem, but I need to split the middle term into 2 parts, the 2 parts that we just said, right? 2x squared plus 3x plus 17x plus 21. Except 14 is what I meant to say. Thank you. For the record, did I do that on purpose? No, I didn't. It was an accident. But you caught my error, right? That's what I do for you when you mess up too, right? And we do it respectfully, so good job. What's up?
Do we just group from here?
Yeah, absolutely, right? We just group from here. Common, and what's common? What's common in the first 2 terms? X. What's left?
X squared plus
2x plus 3, right? Because we took out an x from each term. What's common in the second 2? 7. What's left? 2x plus 3. Now, what if you couldn't think, maybe, because do you guys ever you're working on something, your brain just turns off. You're like, I don't know what's going on.
All the time.
Okay, so if I know that my parentheses has to say 2x plus 3, would that help you sometimes? Maybe think about what to factor out?
Yes.
Yeah, use that if you need to, okay? So what's common?
2x plus 3.
And what's left? Questions? Can I answer a question that you haven't asked yet?
No.
Yes.
Oh, wait, yes. Wait.
You can always answer a question.
What if, you don't have to write this down. You don't have to write this down. What if I wrote this instead? 2x squared plus 14x plus 3x plus 21.
What did you divide
Do you see what I did?
divide by term?
No. Look, do you see what I did though? What did I do? I split the middle term like I normally did, except I wrote the 14 first instead of the 3 first.
You'll get the same answer.
Oh, well, can I prove that to you? 2x, so x plus 7, and then 3, x plus 7, and what's common is the x plus 7, and what's left is the 2x plus 3.
So it just switches the orders of your parentheses, which doesn't matter.
Which doesn't matter, right? It doesn't matter what order we multiply in, as long as we get both parentheses there. Does that make sense? Do you see what I mean when I said, can I answer a question you haven't asked yet? Maybe you hadn't thought about that yet, but now you know. Is that all right? And then we're done. Ready for another example? 5x squared minus x minus 18. Eesh.
That's a rough number.
Okay. AC is what?
Negative 90.
Negative 90. And B is what?
Negative
Negative 1. Okay. So 1 and 90.
Oh.
2 and 45. I know. Let me go. 3 and 30. 4 doesn't work. 5 and, well, 18. That's where I got it from, right? 6 and 15. And then 9 and 10. Now, I know some of you saw it right away, but why did I say let me go? Because will all of you see it right away every time? No, so we have to have a strategy to use, right? Okay, so if this is my strategy to use, which two numbers are we going to use this time?
Negative 10 and 9.
And why? Why is it that way?
Because you have to have
I need the negative 10 and the positive 9 to make a negative 1. We know they have to be opposite signs because AC is negative, right? Okay. All right, now what?
Group it.
Now group it. 5x, times x minus 2. And then?
And 9.
Good. And then what do they have in common?
X.
And what's left?
5x.
Done. Three x to the third plus 5x squared plus 2x. Uh-oh. I can't. Not this time.
Oh, God, it's X.
Can you divide the entire equation by x?
That's exactly what I need to do. Right? Because what am I supposed to look for first every time? Greatest common factor. And these terms have a greatest common factor of x. Right? So if I factor out an x, what do I have left?
3x squared plus 5x
plus 2.
Now I can do AC. Before I couldn't even do AC. Because A is right here, and there's not a C. Right? So now I can do AC. And AC is, and B is So my two numbers are 2 and 3. So 3x squared plus 2x plus 3x plus 2. What about this x though? Am I just dragging it along?
Do we need to distribute?
Yeah, no. Guys, I don't want to distribute when I factor it. I literally just took it out. I don't want to put it back in. Does that make sense?
So just keep
Okay.
dragging it.
I know that you want to distribute because it's sitting out there, right? You want to put it in there, but don't do that. We just took it out. I would just be doing extra work if I put it back in, because then in order to do anything else, I'd have to take it back out. Okay? So, just drag it along, right? What's common in the first two terms?
X.
X. And then what's left? 3x plus 2. What's common in the last two terms? There, you always have to factor something out. So what are you going to factor out? A 1. And then what's left? Okay. Drag that x along. What's common? And what's left? X plus 1. Any questions? All right, last example for you. 4x squared plus 2x minus 12. What do you want to do?
AC.
I don't.
Oh, greatest common factor.
Yeah. Okay. Now, here's the deal. I can do AC here because A is the term beside the x squared, B is the term beside the x, and C is the constant, right? So I have an AC that I can do. But if I do AC right here, I'm dealing with 48, right? Negative 48, yes. I'm dealing with negative 48 and has to add to be 2, right? But if I took out a 2 first, that leaves 2x squared plus x minus 6. If I do AC now, I'm just dealing with negative 12, right?
Does it matter? Like, do we have to do that?
So that's a great question. Do you have to do it? The directions are going to be factor completely. And if you'll give me just a second, I'll show you what you get if you do the 48. Can we do that? Let's finish this example and then I'll show you with the 48. Okay? All right, so what's AC in this problem? Negative 12. And what's B? 1. So what two numbers are we using? 4 and negative 3. And now we're just factoring by grouping. So 2 times, because we're dragging the 2 along, 2x, very good. What's left?
X plus 2.
Plus 2. And then what's common here?
Negative 3.
Good. X plus 2 is what's left. And if I have the 2, what's common? X plus 2, and what's left?
X plus 2x plus.
Okay. If I did AC here, I'd get 4x squared plus 8x plus 6x. That's wrong. Minus 6x minus 12, right? And that would be 4x, so x plus 2, and then negative 6, and then x plus 2, and then x plus 2, and 4x minus 6. That's what I'd get, right? Your directions are always going to say factor completely. What's the difference in what we got taking out the greatest common factor first and not taking out the greatest common factor first?
You still have the greatest common factor.
There's still a greatest common factor here, and if this is what you write as your answer, it is not factored completely because this has a greatest common factor of 2, so I'd have to pull it out at the end. When I pull it out at the beginning, I'm working with smaller numbers. I can still do it. It's just I'm working with bigger numbers.
Yes, ma'am.
Does that make sense?
Yes, ma'am.
Any questions?